Now in this lecture we'll find out the area of the green shape. In the drawing we have a quarter circle ABO. Inside this quarter circle we have line segment PQ that is equal to 3 units, line segment AQ equals to 5 units, and our mission is to find out the area of the green shape. This is actually the area of the green right triangle AQO. Okay. So first of all we'll focus on the right yellow triangle PQA. And we'll implement on this right yellow triangle the Pythagoras theorem. So in the right yellow triangle APQ, by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right yellow triangle APQ is AQ, therefore the square of the hypotenuse is AQ squared, and it's equal to PQ squared. The sum of the squares of the perpendiculars is equal to PQ squared plus AP squared. Repeat again, in the right yellow triangle APQ, according to the Pythagoras theorem, AQ squared equals to PQ squared plus AP squared. So AQ equals to 5, therefore AQ squared equals to 5 squared, that is 25. And it is equal to PQ squared. PQ is 3, therefore PQ squared is 3 squared, it is 9. Plus AP squared. AP is unknown, so we leave it as it is. In conclusion, we found out that in the right yellow triangle APQ, 25 equals to 9 plus AP squared. We subtract from this equation 9, and we get that 25 minus 9 is 16. That is equal to AP squared. We take a root out of this equation and we get that AP equals to the square root of 16, that is 4. We found out that AP equals to 4 units. In the next step, we use a new rule, and we implement the new rule, rule number 2 in our drawing. We have rule number 2, according to rule number 2, perpendicular from the center of the circle towards any chord, bisect the chord. The center of this circle is at this point, point O, and we draw perpendicular on chord BC. So this angle equals to 90 degrees and this angle equals to 90 degrees. According to our construction, we define the touching point of the perpendicular from point O and BC as M. So actually, the perpendicular OM, according to rule number 2, bisect chord BC. That is to say, it divides it in two equal parts. The first half is BM, the second half is MC. So BM equals to MC according to this rule, rule number 2. So whenever you draw perpendicular from the center of the circle towards any chord, it will bisect the chord. In this case, BM equals to MC. So we implement a new rule in our drawing. A or B is a quarter circle, and you can actually complete a quarter circle to a circle, and therefore it is actually also a circle that the center of the circle will be point O. So from point O, that is the center of the circle, we will go perpendicular on AP, on chord AP. So this angle equals to 90 degrees, this angle equals to 90 degrees, according to our construction. We define the touching point of the perpendicular from point O and AP as M. So, according to rule number 2, the perpendicular OM bisects chord AP. And you know that AP equals to 4 units. And according to rule number 2, the perpendicular OM divides chord AP into two halves. The first half will be AM that is equal to 2. The second half will be also PM that is equal also to 2. Okay. In the next step, we define this point as point N. Actually, we define the touching point between the perpendicular OM and the chord AQ as N, and we prove that the right triangle AMN, the right small triangle AMN is similar to the right triangle APQ. Okay, so the right triangle AMN is similar to the right yellow triangle APQ. We define angle PAB, this angle is theta. Therefore, the missing angle, this angle, must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is the sum of the angles in any triangle. Likewise, the missing angle here must be equal to 90 degrees minus theta according to the same rule. Okay. So we'll prove that the right angle AMN is similar to the right angle APQ. First of all, those two angles, they are both right angles, therefore they are equal to each other. So angle APQ equals to this angle AMN equals to 90 degrees In addition, this angle theta is a common angle, it belongs to both triangles, so angle theta equals to itself. That is to say, angle PAQ, that is theta, equals to itself, equals to angle MAN, that is also theta. They are both equal to theta. It is a common angle. Repeat again. Angle PQ equals to angle MAN equals to theta. Again, it is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So, this is angle PQA. That is equal to this angle MNA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. Repeat again. Angle PQA equals to angle MNA equals to 90 degrees minus theta. So actually proved that all the three angles of the small yellow right triangle AMN are equal to all the three angles of the right yellow big triangle APQ. Therefore, those two right yellow triangles are similar to each other according to angle similarity rule. Triangle APQ is similar to triangle AMN according to angle similarity rule. According to angle similarity rule, if two triangles are equal to each other in all of their three angles, that are similar to each other according to angle similarity rule. So from the fact that those two right triangles are similar to each other, we'll conclude that AP over AM equals to PQ over MN, and it is also equals to AQ over AN. It again, from the fact that the two right yellow triangles are similar to each other, we conclude that AP over AM equals to PQ over MN equals to AQ over AN. So AP equals to 4. Therefore, we substitute AP by 4. AM equals to 2. And it is equal to PQ. PQ equals to 3, so substitute PQ by 3 over MN. MN is the missing 9 segments, so we leave it as it is. Equals to AQ. AQ equals to 5 according to what is given as the equation over AN. So here 4, we found out that 4 over 2 equals to 3 over MN equals to 5 over AN. 4 over 2 is 2 equals to 3 over MN. We'll multiply this equation by MN and we'll get that 2 times MN equals to 3. We divide this equation by 2 and finally we get that MN equals to 3 over 2, that is 1.5 units. MN equals to 1.5 units. MN equals to 1.5 units. From this equation we will conclude that 4 over 2 is equal to 5 over N. Again, 4 over 2 is equal to 5 over AN. 4 over 2 is 2 equals to 5 over AN. We multiply this equation by AN. And we'll get that 2 times AN equals to 5. We'll divide this equation by 2. And we'll get that AN equals to 5 over 2. That is 2.5 units. AN equals to 2.5 units. AN equals to 2.5 units. In the we have the rule that any triangle can be blocked by a circle. Therefore, we block triangle AOQ by a circle. So I copy triangle AOQ in a new page and we'll block it by a circle. So peripheral angle AOQ is equal to 90 degrees. Write it down. Peripheral angle AOQ equals to 90 degrees. Here we will implement rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees rests on the diameter of the circle. Here we have peripheral angle ABQ that is equal to 90 degrees. Therefore, according to this rule, rule number 2, peripheral angle ABQ equals to 90 degrees. Peripheral angle ABQ, peripheral angle ABC, this is peripheral angle ABC, rests on the diameter AC. Here the diameter is AC, therefore peripheral angle ABC that is equal to 90 degrees must rest on the diameter AC. Okay, so again, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle, according to rule number 5. So here we have peripheral angle AOQ that is equal to 90 degrees, therefore peripheral angle AOQ rests on AQ, that is, therefore AQ must be the diameter of the circle. Why? Because peripheral angle AOQ that is rest on the that is equal to 90 degrees must rest on the diameter of the circle, and it rests on AQ, therefore AQ is the diameter of the circle. So AQ is the diameter of the circle, that is to say it is equal to 2R, and it is given as the equation that AQ equals to 5 units. So from this equation we conclude that 2R equals to 5. We divide this equation by 2 and get that R equals to 5 over 2, that is 2.5 units. R equals to 2.5 units. The radius of the circle equals to 2.5 units. Okay. So here, before that we have what is the length of line segment QN? The length of line segment QN or NQ is very easy to see that NQ equals to AQ minus AN. AQ minus AN. Repeat again. NQ equals to AQ minus AN. Okay. NQ equals to AQ minus AN. So NQ equals to AQ, that is 5, according to what is given as the equation, minus AN, that is 2.5. So I conclude found out that NQ equals to 5 minus 2.5, that is 2.5. NQ equals to 2.5 units in its length. I'll write it down. 2.5. So actually we found out that the diameter of this circle AQ is the diameter of the circle, but it is given as an equation that AQ equals to 5 units, and the radius of the circle is 2.5. AN is the radius of the circle that is equal to 2.5, and QN, it is also the radius of the circle that I drew here, because it is equal to 2.5. So the touching point between the two radii must be the center of the circle. Very simple. Again, the touching point of the two radii QN and AN must be the center of the circle. Very simple. Write it down. N is the center of the circle. The center of the circle that I drew around triangle AOQ, this triangle, right triangle. Again, N is the center of the circle. Okay. N is the center of the circle. I remind you that we draw a circle around AQO, right triangle AQO. Okay? So, here we have so I will show it here. Here, point N is the center of the circle, okay? Point N is the center of the circle. Point O is the point of the circle itself. This is exactly the definition of a radius. Therefore, NO is the radius of the circle that is equal to 2.5 units. We already found out that the radius of this circle equals to 2.5 units. Therefore, NO, that is the radius of the circle, it is equal to 2.5 units. Okay? So, in the next step, we'll focus on the right triangle AMO. So I'll copy the right triangle AMO in a new page here. Side AM equals to 2 units. Side MO equals to 1.5 plus 2.5. MO equals to MN plus NO. That is to say, MO equals to MN, that is 1.5, plus NO, that is 2.5. In total, it is equal to 4 units. So actually, this is the right triangle AMO that is copied from the original drawing. We implement the Pythagoras theorem on this right triangle AMO. According to the Pythagoras theorem, the square of the hypotenuse is AO square. It must be equal to the sum of the sides of the perpendiculars. That is to say, it must be equal to MO square plus AM square. So AO square, the square of the hypotenuse, must be equal to MO square. MO is 4, therefore MO square is 4 squared, that is 16, plus AM square. AM is 2, therefore AM square is 2 squared, that is 4. So AO square equals to 16 plus 4, that is 20. We take out of this equation, and finally we get that AO equals to the square root of 20. Equals to the square root of 20, so it write it down that AO equals to the square root of 20 units. In the next step, we will focus on the green right triangle AQO. So I copy the green right triangle AQO in a new page, and we implement on this green triangle AQO the Pythagoras theorem. The length of the hypotenuse AQ equals to 5 units according to what is given as the question. So actually, this is the right green triangle that I got from the original drawing. Actually, that is the area that we are looking for, the area of the right triangle AQO. We're looking for the area of the right triangle AQO. So we implement here the Pythagoras theorem. According to the Pythagoras theorem, AQ square equals to AO square plus QO square. AQ is 5, therefore AQ squared is 5 squared, that is 25. And it is equal to AO squared. AO is square root of 20, therefore AO squared is square root of 20 squared, that is 20, plus QO squared, that is unknown. So here is, so we found out that 25 equals to 20 plus QO squared. We subtract 20 from this equation, and we get that 25 minus 20 is 5, equals to QO squared. We take out of this equation and found out that QO equals to the square root of 5 units. So here QO equals to the square root of 5 units. Now it is very simple to find out the area of the green rectangle AQO. The area of the right triangle AQO here, the squared brackets is the sign for the area. So the area of triangle AQO equals to the base of the triangle times the height over 2. So the base of the triangle is QO times the height is AO. Again, the height must create 90 degrees with the base. You can see here that the height indeed, the height AO creates 90 degrees with the base QO, because this area equals to 90 degrees over 2. So finally we found out that the area of the green right triangle QO equals to QO times AO over 2. QO is square root of 5 units times AO is square root of 20 units over 2. So the area of the green right triangle QO equals to square root of 5 times square root of 20 over 2. According to the algebraic identity, that the square root of A times square root of B equals to root of A times square root of B equals to the square root of A times B, we get that the square root of 5 times square root of 20 equals to the square root of 5 times 20 over 2. 5 times 20 is 100, so it is the area, it is the square root of 100 over 2. The square root of 100 is 10, and 10 over 2 is 5. So in conclusion, we found out that the area of the green right triangle AQO is equal to the square root of 5 square units. And that is the answer to the question. Repeat again, the area of the green right triangle, the area of the green right triangle equals to 5 square units. In the next step, I will summarize the lecture. So in this lecture, we found out the area of the green right triangle AOQ. First of all, we focused on the right yellow triangle APQ. I repeat again on the question that we have here a quarter circle AOB. We know that the length of side, the line segment PQ equals to 4 units, and the length of side AQ equals to 5 units, and this angle AMN equals to 90 degrees. This angle equals to 90 degrees. Our mission is to find out the area of the right triangle, triangle AQM. triangle AQO. Okay. So, first of all, implement the Pythagoras theorem on the right yellow triangle APQ. The right yellow triangle APQ, AQ squared equals to AP squared plus PQ squared. Repeat again. AQ squared equals to PQ squared plus AP squared. AQ equals to 5, therefore AQ squared is 5 squared, that is 25, plus PQ squared. PQ equals to 3, therefore PQ squared is 3 squared, that is 9, plus AP squared. So 25 equals to 9 plus AP squared. We subtracted 9 from this equation and found out that 25 minus 9 is 16. It is equal to AP squared. We took out of this equation and found out that AP equals to the square root of 16, that is 4. So here AP equals to 4 units in its length. Then we implemented here rule number 2. According to rule number 2, the perpendicular from the center of a circle towards any chord bisect the chord. The center of the circle is here at point O. So if we draw perpendicular from the center of the circle, that is to say from point O on chord BC, so here, and we define, so this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. The touching point of the perpendicular from point O and BC is M. We define it as M. So the perpendicular OM, according to rule number 2, bisect chord BC. That is to say, BM equals to MC according to this rule number 2. Okay. We implemented rule number 2 in our drawing. ABO is a quarter circle, so we can actually complete it to a circle. Here we can complete this quarter circle to a circle. So we have here a circle, and the center of the circle is at point O. So we draw from point O perpendicular on chord AP, this chord. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AP is M. So the perpendicular OM from the center of the circle, that is to say from point O, bisects chord AP. That is to say, divide it into two halves. If chord AP equals to, because chord AP equals to 4 units, then it bisects OM bisect the chord AP into two halves. That is to say, the first half equals to 2 and the second half MP must be also equal to 2. And then we actually defined the touching point of the perpendicular OM with chord AQ with line segment AQ as N. Okay, then we actually proved that the green triangle, the green right triangle AMN is similar to the green, the yellow triangle AMN is similar to the yellow big triangle AQP. Again, the yellow triangle ANM is similar to the yellow triangle AQP. But first of all, we define this angle PAQ as theta. Therefore, the mean angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is the sum of the angles in any triangle. For the same reason, this angle must be also equal to 90 degrees minus theta if we focus on the triangle AQP. Then, so those triangle AMN is similar to the right triangle AQP. because of the fact that those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so angle theta equals to itself, and finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. Repeat again. Angle APQ equals to angle AMN equals to 90 degrees. Angle PAQ equals to angle MAN equals to theta, it is a common angle, and finally angle PAQ equals to angle MNA, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Therefore we actually proved that the two right angle triangles are similar to each other according to angle similarity rule. Therefore, from the fact that the two right triangles are similar to each other, we conclude that AP over AN equals to PQ over MN equals to AQ over AN. I repeat again. AP over AM equals to PQ over MN equals to AQ over AN. AP equals to 4, therefore we substitute AP by 4, AM equals to 2, we substitute AM by 2, and it is equal to PQ, PQ is 3, we substitute PQ by 3, over MN. MN is unknown, so we leave it as it is, and it is equal to AQ, that is 5, over AN, that is unknown. Repeat again, it's actually found out that four over 2 equals to 3 over MN equals to 5 over AN. 4 over 2 is 2, that is equal to 3 over MN. We multiply this equation by MN and found out that 2 times MN equals to 3. Then we divided this equation by 2 and found out that MN equals to 3 over 2, that is 1.5. Okay, MN equals to 1.5. From this equation, we will conclude that 4 over 2 equals to 5 over AN. Okay, 4 over 2 equals to 5 over AN. 4 over 2 equals to 5 over AN. 4 over 2 is 2, so 2 equals to 5 over AN. We multiply this equation by AN and found out that 2 times AN equals to 5. 2 times AN equals to 5. We divided this equation by 2 and finally we found out that AN equals to 5 over 2, that is 2.5. Okay. So here AN equals to 2.5 and MN equals to 1.5. Okay. Then we have the rule that any triangle can be blocked by a circle. Therefore we blocked the right green triangle AOQ by a circle. This is the right green triangle AOQ, we blocked it by a circle. And we have angle AOQ. This angle AOQ equals to 90 degrees. Repeat again. Peripheral angle AOQ equals to 90 degrees. And we have rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Peripheral angle ABC equals to 90 degrees, therefore peripheral angle ABC must rest on the diameter. The diameter of this circle is AC, so you see that peripheral angle ABC that is equal to 90 degrees rests on AC, that is the diameter of the circle. Here OA equals to R and OC equals to R, they are both the area of the circle. Again, peripheral angle ABC that is equal to 90 degrees rests on the diameter AC. You can implement the rule number 5 in our drawing. Why? Because in our drawing we have, in this drawing, We have peripheral angle AOQ that is equal to 90 degrees, therefore peripheral angle AOQ must rest on AQ. Must rest on the diameter of the circle, so it rests on AQ, therefore AQ is the diameter of the circle. Again, because of the fact that peripheral angle AOQ that is equal to 90 degrees must rest on the diameter, and it rests on AQ, so AQ must be the diameter. So we found out that AQ is the diameter of the circle. Again, here we have AQ is the diameter of the circle, that is to say it equals to 2 times the radius. And it is given us the equation that AQ equals to 5. So from this equation we conclude that 2R equals to 5. If 2R equals to 5, we divided this equation by 2 and found out that R equals to 5 over 2, that is 2.5. This is to say the radius of this circle equals to 2.5 units. Okay? The radius of this circle that blocks the right yellow triangle AOQ equals to 2.5 units. Then we found out the length of line segment NQ. It is very easy to see that NQ equals to AQ minus AN. Again, AQ minus AN equals to NQ. Read again. NQ equals to AQ minus AN. So NQ equals to AQ, that is 5, minus AN, that is 2.5. AN is 2.5. So 5 minus 2.5 is 2.5. In conclusion, found out that NQ equals to 2.5 units. NQ equals to 2.5 units. So we found out that AQ is the diameter of the circle that blocks triangle AOQ. And the radius of this circle is equal to 2.5. So AN is the radius because it is equal to 2.5. QN is also the radius because it is equal to 2.5. So the touching point between the two radii must be the center of this circle that blocks triangle AOQ. Very simple. The touching point of the two radii must be the center of this circle, that is to say point N. Point N here is the touching point between the two radii, therefore point N is the center of this circle. Repeat again. Point N is the center of the circle. Okay. In the next step, we implemented the Pythagoras theorem on the right triangle AOM. So we copy the right triangle AOM in a new page, and we implemented in the Pythagoras theorem MO equals to MN plus NO. MO equals to MN equals to 1.5, NO equals to 2.5. 1.5 plus 2.5 is 4. So MO equals to 4, AM equals to 2. Again, MO equals to 4, AM equals to 2. So according to the Pythagoras theorem, AO square equals to OM square plus MA square. AO square equals to MO square. MO is 4, therefore MO square is 4 squared, that is 16, plus AM square. AM is 2, so AM square is 2 squared, that is 4. So AO square equals to 16 plus 4, that is 20. AO square equals to 20. We took out of this equation and found out that AO equals to the square root of 20 units. Then we implemented the Pythagoras theorem on the right grand triangle AQO. This is the right grand triangle AQO that I copied from the original drawing. AQ equals to 5 units according to what is given us in the question. AO equals to square root of 20 units according to what we just right now found out. So this is the missing side. According to the Pythagoras theorem, AQ square, let's go the hypotenuse, equals to AO square plus QO square. So AQ, the hypotenuse, is 5, therefore AQ square is 5 square, that is 25, and that is equal to AO square. AO is square root of 20, therefore AO square is square root of 20 square, that is 20, plus QO square. So 25 equals to 20 plus QO square. We subtracted 20 from this equation. 25 minus 20 is 5, so 5 equals to QO square. Then we took out of this equation and finally found out that QO equals to the square root of 5. Here QO equals to square root of 5. Here QO equals to the square root of 5. Now it is very easy to see, to find the area of this right green triangle AQO. The area of this green right triangle AQO equals to the base of the triangle times the height to the base over 2. So again, the area of the green right triangle AQO equals to the base of the triangle times the height to the base over 2. The base is QO, the height is AO over 2. So it is QO times AO over 2. Here, the height of this green right triangle is AO because the height AO creates 90 degrees. AO creates 90 degrees with the base QO, therefore it is the height. Because the height must create 90 degrees with the base. So in conclusion, found out that the area of the green right triangle AQO equals to QO times AO over 2. QO is equal to 5. AO is equal to 20. Again, QO is equal to 5. AO is equal to 20 over 2. We have the algebraic identity that the square root of A times square root of B equals to the square root of AB. Therefore, the square root of 5 times square root of 20 equals to the square root of 5 times 20, all divided by 2. 5 times 20 is 100. In conclusion, found out that the area of the green right triangle AQO equals to the square root of 100 over 2. The square root of 100 is 10 over 2. 10 over 2 is 5. So finally, we found out that the area of this green right triangle AQO equals to 5 square units. Okay, thank you very much.